all the way through. The most challenging one is you'll always get a problem that involves cutting some corners out of a cardboard piece, a rectangular piece, and folding those sides up and making some kind of volume. Because why not? Classic math problem in every class you've ever taken, right? You've always had one of these, right? It always seems to come up. And of course the box has no lid, because for whatever reason that throws everything off. Now I know what the reason is. Because if there's a lid, if it's a closed rectangular prism, then it's too easy. It doesn't require calculus. And in fact, this technically doesn't really require calculus, although we're gonna shoehorn some calculus in it. The idea is that if it's a rectangular prism, a solid, the figure with the max volume would be a cube. So you're like, all right, so take whatever the dimensions are and work it out so that it's a cube and go from there. But we don't put the lid on, so we make it a rigorous math problem. Rectangular box with no lid is to be constructed from 12 square meters of cardboard by cutting square notches out of each of the 4 corners and folding up the remaining sides. Find the maximum volume that such a box can have. All right, so now the understanding here would be using Calc 3 concepts. All right, so yeah.
Because I was like, that doesn't.
That's definitely not a box. Yeah, certainly not. Yeah, so let's actually draw a box. Oh, shaded it for me. Yeah, I did that by hand. That joke is not even funny, but I like it, so I keep going with it.
Do it for yourself, not for us.
That's horrible. See?
Yeah, that's my penance.
Fails you.
Yeah. Oh yeah, most of the jokes that I make are for myself. They have to be. Because like a good 75 to 80% of them are not funny. To anyone else. I mean, I find them hilarious. And unfortunately, so does my son. Unfortunately for him, because like I think they're hilarious, but they're not always going to go over well at school. So I try to warn him. So we practice at home. Like that's good for school. That one's not. Don't use that one in school. They're going to think you're a dork. That one's funny, and so on. You know.
Your son said what?
Oh, I'm waiting for those days. Yeah, so he's like 7 years to go, baby. Yeah.
Oh my god. He's just waiting to use his words.
Oh yeah. Well, he's waiting to do it in front of me and get away with it, you know. And then I had to go through the whole know your audience thing, like you can say this in front of me, but don't say it in front of mommy unless you want to die. There's all sorts of different things, you know. But anyway, none of that has to do with a box, so I might as well get to it. So anyway, there's 12 square meters of cardboard, so we're going to cut out the notches, and that's going to give us the height. The issue is we don't know anything about the dimensions. That's what makes this different from other cardboard box questions that you might have dealt with in the past. Right? So we know that we're going to have, let me just define this. I'll call it, I don't know what I want to call it. I'll call one side X, obviously. All right, because the whole shebang should have an area of 12. So the other dimension, I could just say is 12 divided by x. All right, so we have that. But then we have the little notches that are cut out. Now, hopefully we agree that these two multiplied together give us 12, so that satisfies that requirement. I'm going to call, well, I've used x, so I'll call this y, each one of them. You don't have to label them all, but I've committed, so here I am. All right, so if I want the volume of the figure, I need the base area and the height. The height is going to be y because when you fold up these flaps, they're going to have a height of y. Right, so that part's easy enough. It's just a matter of saying, all right, well, I have a length of x. I'm removing 2 y's from that x. For the vertical piece here, I have an overall length of 12 over x. I have to remove from that 2 y's also. All right, so my volume, which is length times width times height, is going to be x minus 2y, 12 over x minus 2y by y. Now, instead of calling it v equals, I'll say f of x comma y equals, because it is a function of 2 variables. Now, you can go after this a couple of different ways in terms of the differentiation. I think it makes sense to distribute a little bit first. It'll make life a little easier in the long run. And calculation-wise, it's not too crazy, so might as well. But I'll do it 2 at a time instead of just trying to muscle my way through it. So 12 over x times x is just going to be the 12. Minus 2xy minus 24y over x, clean that up in a minute, plus 4y squared, all multiplied by y. Just a little old-fashioned FOIL, which apparently they don't teach anymore. Not, you know, the word FOIL, they teach it in other ways. Let's see, just double check. Yaw and a yaw. Okay. So we're looking at 12y minus 2xy squared minus, I'm going to write this as 24x to the negative first y squared and then plus the 4y cubed, just to keep everything on one line, make it power rule friendly. All right, and so the question comment before was related to the graph. This graph is for this function. All right, so that's what it would look like. And really, I didn't put that graph there as an aid as much as it is to show how sometimes the graph is not an aid. Right? You look at it and say, all right, well, maybe there's a minimum or a maximum in there. In this case, we're looking for max volume. Maybe somewhere along this ridge. Maybe this is a max. Based on perspective, it's hard to tell. Basically, what we're getting from this is that the graph is not overly helpful, which is further reinforcement behind the idea that the second derivative test is a good approach to take when it comes to questions like this. All right, so first order partial with respect to x. All right, so ignore the first term. Second term, we're looking at, we got negative 2y squared. Then we got plus 24x to the negative second y squared. Oof, I'm going to clean that up a little bit. Now, when we go for our second order partial, I'm going to work off of what I just wrote, but in terms of solving for the critical values, we may want to kick it over into a different form, so I'm going to write it both ways. All right, so I'll do it like I did last time. Just go through my my partials first, get that out the way. So I want my second order partial with respect to x. And if it's convenient enough, I may get the mixed from this. It seems all right. So, again, I'm holding on to my second variation here, the one with the fraction, just for later. For now, I'm working off of this bad boy. So negative 48x to the negative third, y squared. And then, like I said, I don't think it's too terrible to figure out the mixed from this. And we may have continuity issues anyway, so we might want to figure it out both ways, just make sure that we're not going to have an issue there. So negative 4y to the first plus 48 x to the negative second times y. All right, that's all calculation stuff that we'll have to take care of later once we figure out what our critical value or values are. This is shaping up like one of those situations where we're hoping for not too many critical values. But we kind of see where this is going. So first order partial with respect to y, so back to our original function. So I'm going to have a 12 minus 4xy minus 48 x to the negative first y plus 12y squared. I'm going to arrange the chords. Quick double check a Ruski here. Seems all right. If it's not, I'm sure you'll let me know. So second order partial with respect to y, so negative 4x minus, let me make that a better looking x, minus 48 x to the negative first plus 24y. And then let me do my mixed on this end and see what we're up against. So that goes away. We're doing this with respect to x, so negative 4y. Then we are looking at plus 48x squared. Okay, so it does check out. Because we're doing it with respect to x.
No, yeah, it might be x squared negative
X to the negative 2.
You fyx?
Oh, no, wait. Yeah.
Oh, negative second?
Yeah.
Yes.
X to the negative second.
And there it is. All right, so we got what we need there. Let me clean up my first order partial, which I probably should have done already. Oop, poor quality 12. 12 minus 4xy minus 48y over x plus 12y squared. This is going to be pretty something. Nah, it should be all right. Should be fun. Going back to the first order partial with respect to x, I have a common y squared. You pull that out. You could also pull out the negative 2 if I want. I guess I want. So 1 minus 12 over x squared. Set each of those factors equal to 0 and solve. So negative 2y squared equals 0. And then 1 minus 12 over x squared also equals 0. So the y part's easy. That's just 0. The other part I got to do a little bit. X squared minus 12 equals 0. So x is equal to plus or minus the square root of 12. So plus or minus 2 root 3. Add the 12 and take the square root. All right, so that's some critical value action going on there. So that brings us to the other guy, which is not nearly as attractive. All right, so substitution is always going to be involved when it comes to this because we need our critical values to be equal to, our first order partials to be equal to 0, but also equal to each other in order to flesh out what our critical values are. All right, I know that they're going to be made up of plus or minus radical, 2 radical 3 and 0, but is this 2 radical 3 going to go with a 0, or maybe there's another y that's going to come out of this that the 2 radical 3 goes with? What we have to do is plug these babies in and see what it gives us as a result. All right, that'll give us our ordered pairs, which is infinitely more entertaining. That being said, plugging in a 0 for y is probably the best case scenario here. All right, so, and in fact, as best case scenarios go, yeah, contradiction, right? So 0 equals 12, so that one's out. All right, so not a critical value. All right, it gives us 0 for one, but not the other. So it would have been nice if that was the winner, but unfortunately not the case. But at least it knocked a third of our work down. Well, not really. Just trying to make it seem nicer. So I'll go with the 2 radical 3. At least to start. Simplify. So that's going to be 24 over radical 3. Ooh, hello. That moved on me. All right, it's a function of one variable, so you could definitely go after this with your calculator, type it in, see where the x-intercepts are, but if you're looking for a clean answer, if there is a clean answer to be had, you're probably not getting it from here. All right, so a different approach, something you may be familiar with, but let me put it in a little bit more of a user-friendly form. I'm going to write it as 12y squared, and then plus negative 8 root 3 minus 24 over root 3 times y plus 12 equals 0. All right, so all I did was reorganize a little bit. I factored out a y. But the reason why I factored out a y is I put it in the general form for a quadratic. So ax squared plus bx plus c. The reason behind that is so that we could use our quadratic techniques. That's assuming you wanted to do it by hand. This old gem here. What's that? Yeah.
Can we clean that?
That is pretty clean. You could have done it in the calculator, been done with it already. Absolutely.
I don't want to do this anymore.
Now, as common denominators go, what do we get if we do that? Negative 48 over root 3?
I think you just get negative.
Let's go ahead and
Or,
calculate.
sorry, oh,
Wouldn't this be negative 8 minus 24?
Negative 48 over root 3? If I multiply top and bottom of this by root 3?
8 times 3 is not.
24, yeah.
24 negative 24 minus 24 is negative 48 over root 3.
Yeah.
So there's that. I mean, it's not the best consolation prize in the world, but so instead of x being equal to negative b over blah, 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 it's y equals, because that's our independent variable, but 48 over root 3 plus or minus the square root of 48 over root 3 squared, so I'm just going to write 48 squared over 3 minus 4 times 12 times 12 all over 2 times 12. Indeed.
Negative 48?
No.
No.
It's, negative, the negative b.
Oh, yeah. So like the inside though.
It's squared.
Squared.
Oh, that's not.
A little bit of math. A little bit of math for you.
So that 48 squared over 3 is 768.
768.
So just that one part, that 48 squared over 3.
Just radical
I didn't subtract it.
162.
Yeah. Or 192, sorry.
Oh, 192. So is that 14?
Radical 192, which is 13.86.
So radical 192.
Yeah.
Oh, because 196 is 14, right?
I couldn't just write that as plus or minus 48 over radical 3. Because are we accounting for both of the possibilities that x could be?
Say it again.
So, are we just only gonna look at the positive 2 radical equations, or can we just consider both here, but never getting left again?
Yeah. Well, actually, I think it works out. Does it work out?
No, because you would have a negative in the,
Oh, you'd have a negative inside.
or you, oh, sorry, that should be negative in front having to work. Or that should be yeah, that should be negative out front having to work with the negatives.
If I put in 2 negatives here, these become positive. So that would make this whole thing positive. So that would reverse this.
Yeah.
And that would be the only thing. Okay, so we could do that. A little time saver.
What? I don't know what we
Okay, so we're not going to do that.
I'm not as quick, I'm sorry. What was that?
It was the idea that if you were to substitute in the negative 2 radical 3,
Would all be equivalent.
these
for
would be
that.
positive. The only thing that would change in this entire calculation would be that this would be the opposite sign, the 48 over radical 3. But we'll deal with that in a separate step. Yeah. So let's see. 192, does that simplify
No,
at all?
It's 13 point, oh.
it's 13.8, like, it's a.
You mean
irrational.
simplify as in make it a smaller radical?
Yeah.
It was on the 13.85.
No, there's a,
It
I don't know
can't
how to do that
because
stuff.
It's like a 13.
4 times the square root of 12.
Yeah, so 8 root 3? Yeah. And 8 root 3 we established before was 24 over the square root of 3, right?
Yeah.
You good?
We did. Yeah, all this calculus is crazy.
This is the easy part.
Yeah.
Yeah.
Same thing we did here. The easy part, it's all the algebra and stuff that we just forgot. That I know how to do.
Oh, that-
I'm not that dumb.
So 1 over root 3 is going to be one of the solutions. And then the other one, we're looking at what, 72 over 24? So 3 over root 3? Now, it is doable. You could get this with the calculator and still end up with the exact value. It's just you would have to make the assumption that your funky decimal, when you go through the process of setting this equal to 0 and solving, you know, by finding intercepts or whatever approach you want on your calculator, you would have to operate under the assumption that that it's the square root of some number, right? That it's not, you know, some multiple of e or pi or something like that. In which case, you would then know to actually square that result to get the equivalent radical. So I mean, it's a little iffy, but certainly doable. Anyway, what we get from this is that there are, and we'll get to the other possibilities in a second, we plugged in 2 radical 3 to start, so we have critical values of 2 radical 3 and 1 over root 3. We also have a critical value of 2 radical 3 and 3 over root 3. Now I just got to account for the negatives. All right, and so the idea again was just going back instead of reinventing the wheel. If we had substituted in a negative 2 radical 3 instead of a positive, these two numbers would have ended up being negative. If these two numbers are negative, that makes the b value itself negative. Instead of being a negative 48 over radical 3, it's the negation of that. I meant to say negation. It becomes positive 48 over radical 3. If that's the case, then when we plug it into the quadratic formula, the first term is now negative, everything else remains the same. Right? So all of this work remains the same, except I would have a negative 48 minus 24, which would be negative 72 over 3, which would be, over 24, which would be negative 3. All right, so negative 3 over root 3. And then a negative 48 plus 24 would become a negative 24, divided by 24 would be a negative 1. So we get the same values, just negations of those.
It's gonna end up with x inside radical 12, or radical 12.
Oh, I'm sure it will. Honestly, I don't remember. But I'm sure it's going to be some anticlimactic thing where it's like, oh, I would have guessed that. Well, actually, the way it's shaping up, maybe not. Because we just concluded that critical values would be made up of x values containing 2 rad 3 and all this stuff.
Okay.
So All right, well, anyway, now we gotta test these.
Great.
So that comes back to this stuff.
How many questions on a test?
A fair amount, yeah. Yeah, the tests don't get easier as the semester goes on, so.
This isn't like number 5 through 9?
No, imagine if you broke it up into parts and the parts were 5 through 9.
Oh, I just go to 0 because that would be the one I omit.
Yeah.
No,
No, you wouldn't.
I'll drop that test.
You need to know one problem for most of the tests.
That'd be a bad test. That'd be the one problem you didn't study. It's like,
Yeah, we'll talk about the test down the line. There's no need to get everybody depressed tonight. So, yeah, we got to apply the second derivative test now, because I mean we did all the background work, but we still got to crunch these numbers, all right? I mean, I was going to say the good news is, but there really is none. Like you just look at it, it's like there is no good news here. Well, the one thing is that we do need f of x, the second order partial with respect to x, for pretty much all of these. So we can crank this out. The good news is related to that. Well, it's essentially the same number with a different sign each step of the way. So I can get that taken care of. All right. So, and again, we'll do the easy thing first, I guess. Second order partial with respect to x. Now, this is specifically related to those x values that we have, 2 radical 3 and negative 2 radical 3, but also the corresponding y values that go along with them. So, but the good news is there, well, I'll show you.
Can we just write down the sum?
All right, so I'll do the negatives first. So negative 3 over radical 3 and negative 1 over radical 3. And the positives. Oh, jeez. I'm already losing track. Yeah, positives go with positives. Okay, that should be enough to keep track of.
Why are these the square roots of such big numbers? They're just the square roots of really big numbers, like 3.5 million things.
That sounds great. All right, so negative 48, the x value cubed, negative cubed that is, but essentially cubed. The y value squared. And anyone that would give us a second order partial with respect to x, that is not what we're looking for, we can dismiss, because ultimately it would fail the second part anyway. Right, so this would be a negative. So, oh wait, positive, sorry. It's a question of what it is and what I want it to be. The next one, I'm just gonna write it in, and then we'll yay or nay it. Looks like it has the same ingredients. You cube something that's negative, it's going to remain negative. Multiply by positive, it'll become positive. Square a positive, it's positive. So this whole thing is going to be positive. So regardless of what ends up happening with our discriminant, if these are positive, it would give us the wrong kind of extreme value anyway. So that's good news. So negative 48 multiplied by 2 rad 3 to the negative third, 3 over rad 3 to the second. That one's definitely negative, right?
Yep.
So this is a keeper. And the last one would also be by the same convention. a keeper. All right, so we cut our work in half. Remaining work in half. I mean, we still got work. All right, so now I need f of yy, but now working off of the relevant components. So -4 times 2 root 3 minus 48 oh, and I'll actually need those values, so I'll get to that in a sec. I lost my place. 2 root 3 to the -1st plus 24 times 3 over root 3. All right, so I'll crunch that all in a sec. This is a job for the calculator. All right, unless it actually might not be too terrible to do it by hand. All right, I'm just gonna crunch it.
If we had enough paper, it'd be great.
I was gonna say, for the first time, I was like, got plenty of room here now. This is
Yeah.
Nope.
First time ever, but alas.
Oh, you guys talking about?
Get a question to please.
Should have wrote on top, write small.
Yeah. One divided by the square root of 3.
It's always a calculator. Oh, it's even worse.
All right, I completely lost track of which one I just computed, but one of them's -2/3. Well, let me just see here. This one.
Oh, that's funny.
Oh, I
I
did
can do
not
that.
get -2/3 when I did that.
Oh wow.
Just zoom this paper in real quick.
Yeah, that's all you gotta do. I mean, in the end.
Wait.
This one apparently is just a -2. This is surprisingly gentle. -48.
How did you get either of those?
Well, I type stuff into the calculator.
Hold on, let me check something.
About the calculator, do it real quick.
No, I typed stuff into the calculator too, that's why I'm asking.
But I'm liking my
Oh,
answer,
you
so.
forgot to square the y.
Ouch.
That's why it's not ugly.
Oh, dang it. Okay, well,
Oh, for the second, yeah, for the first one.
yeah, these are much nastier. Okay,
Dang it.
so then,
Sounds like they're both irrational. Negative,
well, I'll go back to that one in a second. This one's 8 root 3.
Oh, wait, and I'm gonna.
I'll fix those two jammy jammies in a sec. One semester I taught a Sunday class. There was an Easter break for that.
Okay.
So that was nice.
My old high school has 2 weeks off. I'm like, isn't that nice?
2 weeks.
2 weeks. Because I called for them to send my transcripts to a couple of colleges want transcripts. And yeah, we're going to be closed for 2 weeks. I'm like, 2 weeks?
That's extraordinary. I only got 1 week. I mean, I'll take it. Don't get me wrong. I mean, like, I'm not an animal.
Because you're kind of stuck here, too.
Yeah, there's that part
I mean,
of
you
it.
can take off.
Yeah, it didn't go over well.
No, I'm like this. And then I can go there.
So -8 root 3. Yeah, so those check out. Now let me go back and grab those other ones. So I did not square it, is what you said. Okay. Understood. Make sure I typed in everything else the right way. Okay, squared. All right, so -2 over 3 radical 3.
Oh, okay.
And -2 radical 3. Yeah, there we are. Oop. All right, just so you have it, or at least have a sense. All right, so after all that, we finally got something that actually played out. Now,
Plug that into.
now we got to actually answer the question, because it's saying find the maximum volume that such a box can have. So x minus 2y. (12/x minus 2y) multiplied by y. That's the volume formula. We call that f of x comma y. So we run this through the mill. 2 root 3 minus 2 times 1 over root 3, so 2 over root 3. 12 over 2 root 3 minus 2 over root 3 multiplied by 1 over root 3. Although, if you wanted to, I suppose you could go to the simplified form and work off of that, but I think one is just as complicated as the other. So, I mean, you may even consider distributing through the 1 over root 3 to see where that gets you. But I'm just going to pop it into the old calculator here. So 6 over root 3. Root 3, 1 over. All right, well, let's see if I typed any of this incorrectly.
It's all algebra. It's a lot of computation.
So it's just, it ends up being equivalent to, well, actually, I didn't even check to see if the original thing was math frackable. Because we're looking at something that would be equivalent to 256 over the square root, square root of 256 over 27. So,
If it's on a test, we just leave it as National Decimal.
it depends on the instructions.
It's literally 2 minus 2 or 3 times 2 minus 2 or 3.
That's right.
If you run out the.
Oh, look at that.
Got somewhere.
Got an answer.